Hello everyone, as promised, this is how I did my real estate visualization. In this case, this is the world map visualization. If you don't know what I'm talking about, I will have a link in the description. Overall, let's get started. So, in order to actually preview our data, I used a software package called Geoda. Geoda is for working with geographic data, such as shapefiles. That is what I will be using to preview the data. I find it difficult to preview and explore the data in Python sometimes, so using this package, as we will see here. Don't want to do that. If we go ahead and open up the C-shapes file, which is just a .shp file, take a look in my folder here. It is cshapes.shp. I'll have a link for this in the description. Going back into Geoda, if we take a look at the table view, we can see our data in a spreadsheet format. Some of the things you'll notice is that there are duplicate country names. That is actually how I originally figured out that this is going to be querying out by country name for a specific time period. If you take a look at the documentation, the specific ones that we'll be using are the CWS year, CWE year, GWS year, and GWE year. Those will help us determine what dates and what times are valid for that specific shape. In this data set, shapes are only valid for a certain time period, so there will be some things or some tricks I'll be doing in order to get it to look the way I want and to make an animation out of it. If you ever have trouble previewing your shapefile data, I highly recommend Geoda. I will link it in the description. So going back into Python, I'm going to open up one of my Jupyter notebooks. I have it open here. The specific package that I'm going to use is called GeoPandas. It's pandas data frames, but for geographic data. And we are going to load it up inside of a data frame by running this here. And if we take a look at the head of the file, it looks just like how our file looked when we started in GeoPandas. The one cool thing about this one, it has built-in matplotlib. So if we do data.plot, and by choosing a fig size of this will actually set the resolution to be really high. And when I'm exporting the images, we're going to be using that really high resolution so that we can zoom in on specific areas. Plotting it, it looks pretty awesome. So there was a specific trick that I had to do in order to get this to work the way I wanted. So if we take a look at this right here, this color or this value right here will determine the color of the shape. And when you're doing an animation and certain shapes are valid for certain years and others are not, sometimes a country, even though it hasn't changed shape, will be a different color based on its area relative to other valid shapes in the data set. It's a little confusing, but in order to get around that, I basically set the color to be a random value or the area to be a random value and assign that to a specific country. One thing that I noticed is that USSR and Russia, while they are the same location roughly and they do change shape, I wanted them to stay the same color. So I basically modified this data set to set the name of Russia to USSR, just so that when I loop through the data set and assign it a value, it will basically stay the same, or it will stay the same. This is how I'm doing that. This function right here, or this right here. Anyways, querying out the data, this is a sample of how to do it. You pick a specific year, you query it out based on the CWE year, where the year is greater than or equal to that, and where the CWE year is greater than or equal to the year. I just said that wrong. Anyways, the CWE year cannot be null or -1. And doing the same thing for the GWE year, we set that to a new data frame, and we create a plot, and we can save it. Choosing a DPI of 900 and a quality of 100, along with the fig size of 11 and 6, will render a very high resolution image. We go into here, properties, details, we can see that this is a very large image, 9,900 by 5,400. When we actually go and edit it in Premiere, this is going to help a lot because we can zoom into specific areas. Anyways, back to Python. What I basically did is, in this notebook, is there's a lot of exploration that was being done. I'm going to post all of this to GitHub so you guys can see what I'm doing. But one thing that I noticed with this package in specific that I thought you'd like to know is when you do a for loop over each of the years and save the figure, there is currently no way to clear the figure from memory. So when you are rendering out these high resolution images, they are being added to RAM and you cannot clear them until you restart your kernel. So in order to get around that, I grab whatever images that I've currently exported and I save them to a list. And if the file name that I generate here is not in that list, it'll render it. That way, when I got to a point in which my program would crash, I could just restart the kernel and loop over all the different years that I haven't done yet and save the image. Hope that makes sense. You can try by creating a new folder, such as just /years, and then trying to go through 1946 to 2016, exporting all those images. You're going to find that your RAM usage is going to go way up. My RAM is 16 gigabytes, so I tend to run out kind of quick. Anyways, this is kind of what it's doing. It's creating a bunch of maps in memory and saving it to a file name. That is basically how I did it. I have 3 notebooks here. They all have a different way of me exploring the data. If you have any questions, please leave a comment below. I hope this helped. Thank you for watching.